Genesis of atmospheres or assimilated. XR Genesis mission. Please feel free to download the integral text in PDF format by clicking here. Note, several satellites and other planets have already been the subject of technical remarks in this agency presentation. The purpose of our mission is to determine which means are available to the first settlers in order to install a colony on a celestial object, planet or moon, or on an orbit, that would possess considerable resources capable of ensuring their survival. It is reasonable that the first settlers would arrive in limited numbers aboard of a spacecraft originally built on the moon or on the terrestrial or lunar orbital place. Indeed, the release speed of ejection on the moon is lower of 1/6 compared to that on the Earth, and the construction of a spacecraft destined for colonization could be dimensions of 300 to 500 meters, poly-shaped cylinders, spheres, toroids, or 300 tons, on the moon base. His lunar weight would be close to 50 tons, much easier to launch. Click here to be directed to some information about the moon. The moon. It would be better and easier to build on the moon, rather than to assemble in orbit a large spacecraft. The propulsion required for the release could be provided by liquid hydrogen engines coupled to high-density plasma motors, patents 2006 to 2016. It would not be necessary to use solid chemical propulsion in order to free oneself from the lunar attraction, especially since the basic chemical raw materials for chemical propulsion do not exist on Moon: liquid oxygen and compounds unstable nitrogen. Only fundamental and vital resources exist on the Moon, including water. This water could easily be decomposed into hydrogen and oxygen by many nuclear power plants producing sufficient electrical energy. The payloads made available to colonies 2020 to 2025. A recent agreement has been signed between NASA and Russia for an orbital station, proof of the important interest for Moon. For the characteristics of a terrestrial launcher, we can quote the Saturn-V, with a payload of 45 Earth tons or 7.5 tons on the Moon, so to speak. Click here to be directed to some information about Saturn-V. This first payload could consist of a first lunar module equipped with powerful engines that would be assembled with other lunar modules, at least 5 in number, in order to constitute the final ship on for the Moon or lunar orbit. Then this ship might consider trips to Mars or other planets and moons. The lunar base solution is preferable because settlers could build parts of additional vessels and habitable domes on the ground or underground, and thus apply the plasma technologies to manufacture many necessary materials. Oxygen could be removed from ice, water or rocks by simple or plasma thermal dissociation, thermolysis. Oxygen could be low enriched with helium 3%. Some of the breathable nitrogen could be obtained by applying the plasma tools to the lunar rocks. Nitrogen is a gas that our breathing uses and rejects during pulmonary circulation. It is not vital to lung life. However, biological nitrogen must be absorbed by human via food only for participating in the cycle cellular and genetic, purine and pyrimidine bases, AGTC, U. Nitrogen, N, is an essential component of DNA, RNA, and proteins. Click here to be directed to some related information. Basaltic rocks very rich in nitrogen could be discovered in shallow hard Moon, the Moon having lived volcanic or magmatic periods in the past, when it possessed a magnetic field. Preliminary conclusion, limited. It can therefore be concluded that the atmosphere's nitrogen, oxygen, and helium will be available on the Moon by chemical means of high temperatures, chemical engineering, and by electrosynthesis. As well, considerable liquid water reserves could be available. Warming of ice zones on polar surfaces or average depth, 300 meters, frozen lakes, Moon spectrometry will verify. The Moon has been bombarded for 2 billion years by solar and or cosmic radiation. When the lunar magnetic field disappeared, lunar atmosphere quickly was exhausted, all the more because the gravity is 1/6 m of that of the Earth, and it attracts less easily the N2O2 molecules that could have been present 2 billion years ago. It won't be necessary to bring a large amount of initial resources from the Earth for use on the Moon. PERT heliotor-type plasma tools will be essential. There are other variables on the Moon or on other celestial objects that will depend on the advancement of our technologies. Genesis of a partial lunar technology atmosphere. It will not be necessary to consider the significant creation of an atmospheric reserve. The creation of domes or structures weakly permeable to UV and cosmic radiation cannot be composed of polymers that are generally transparent to electromagnetic hard radiation. Only silicates or borosilicate glasses can represent a protection for the colonies. UV radiation could be conveyed by mirrors in some agronomic, hydroponic greenhouses. The UV radiation of plasma machines installed in domes could serve as artificial UV sources for agronomic or biological areas. Some domes would be partially coated with special optoquantum layers manufactured by ultra-pure plasma processes to provide some of the electrical energy and would relay some of the relaxed thermal energy into spheres or agronomic zones. It is logical to conclude that settlers will be able to settle on the Moon or in Moon orbit in order to safely prepare trips to Mars or other planets and moons with an excellent control of colonization. The following note is linked to the missions XR-PROP and XR-COL. Moreover, it is possible that the research and development of more powerful plasma engines of 10 kN and more, compared to the chemical propulsion system, allow accelerations of more than 30,000 to 300,000 seconds, SI, specific momentum, some developing in other laboratories and at ionic speeds of 1,000 km per second or more. It does not currently exist known plasma methods able to deliver ionic velocities of more than 100 km per second. The ideal plasma engine should eject in the deep space the ions at 10,000 km per second or 100 times faster than the velocities obtained on Earth. This challenge can be overcome, with new plasma technologies that will emerge in a decade, 2017, to be utilized at 36,000 km altitude, Earth, or in lunar geo-orbit. VASIMR currently works for 2017 with a relative force of 5 Newton. The VASIMR 200 engine delivers during 1000 seconds, SI, of ejection of ionized xenon atoms from the plasma, xenon at 50 km per second. Complicated calculations must be made taking into account the drift velocity, v. The progression of the drift velocity is logarithmic. Consult the mission XR-PROP or XR-COL. It is clear that with such speeds of propulsion even at 3/1000 m of the speed of, c. 300,000 km per second, will require the spacecraft to detect the objects which can collide with it. The detection will have to be fast and most anticipated. Only quantum machines in development will be able in real time to carry out these calculations of detection and prevention and corrections of trajectories in case of imminent danger. Lunar requirements in various artificial atmospheres will be easily elaborated. The oxygen coming from the electrolysis zones, and some helium, and a percentage D of nitrogen, which mechanically serves the pulmonary alveoli but whose biological action is useless. Further studies of vital gas mixtures will have to be tested on the Moon, before considering long stays on the Moon, given the differences in gravitational force. Studies of gaseous mixtures in the absence of gravity cannot be extrapolated to lunar conditions. Mars. The atmospheric pressure on Mars is very low, 100 times lower than on Earth, and does not allow its thermolysis in simpler chemical elements carbon and oxygen by the plasma tools. The creation of special synthetic atmospheres, O2, N2, carbon, helium, argon, xenon, and O3 will be carried out from volcanic rocks on the surface, sediments, and semi-deep and water which are mainly composed of silicates simple or complexed with aluminum and sodium. The PERT agency plasma tools will be used for these Genesis missions. Domes and cockpits for robots and men, ground and underground, would be built according to the processes already described in XR-COL and XR-SPACE-I and XR-PRSE sections. Logically, the first operations would be carried out from prefabricated materials in small quantities in orbit and assembled robotically on the ground. The technological vessel could come from the Moon. The Martian and terrestrial gravity being substantially the same, the plasma engines for the return of technological space shuttles, having broad plates and other materials on Mars, should be more powerful than those having been built on Moon. The installation of laboratories on Mars, including agronomic zones, would be developed later, because they require large quantities of oxygen and a little ozone, which the vital immediate production destined for the colonists could not ensure, the first plasma tool serving for the immediate elementary spots. The complete engineering of a colony implantation in the solar system is the subject of this presentation, although many guiding elements have already been described. Contact us at Glycan Industries LLC at glycangroup.com and Michael Glycan SpaceXR at glycangroup.com.